Hey guys, I'm Sabrina. This is Holly. Today we're going to be talking a little bit about rock identification today. This is something that geologists do a lot when they're out in the field. They find a rock, they got to figure out what is this rock that I have. So there's all kinds of ways to figure it out. So they have, first, when they see a rock, they can generally think about their location and the kind of rocks that are there, but if they're not sure, there's a couple of processes that they go through to figure out what kind of rock is what kind of rock. So the first main one would be, but it's not very reliable, would be color. So I have all these minerals and rocks right here that are a lot of different colors. So I've got a lot of white ones, so it's not reliable to look at a rock and say, oh, it's white, so it's this rock or it's this mineral. So, but that is one, so if you know you're in an area that only has limestone and you found this color limestone, you can pretty much tell what it is. So our next identification would be the luster of a mineral. So right up here I have, so a luster of a mineral would be how a mineral reflects light. So you have metallic luster and you have non-metallic luster. So our metallic luster would be this galena rock right here. So if you can see that, it has a metallic kind of shine right there, and that is galena. And then our next one would be our gypsum, is this one. This is gypsum, and it is a non-metallic, but it's also a glass-like non-metallic mineral. Yep, and then this is hematite, and it is also non-metallic and has a dull luster. So those are the three kind of types. Yep, cool. Alrighty, and then our next process of identification would be a streak. So you can get a rock, and we have a streak plate right here. I'll give that to Holly. And then if you'll do this one, this is hematite again. It has a really distinctive red, sometimes orange, brownish streak. And that is just the color of how the mineral powders. So there you go. And then right here is pyrite, and it has a gray streak. Cool. Awesome. And I'll take that. Alrighty, there are also, a lot of our minerals are formed in certain ways, and they make crystals, and the way that the crystals form, they all form in different shapes. So a geologist can tell by the way a rock is shaped what kind of form it has by its crystals. So the next process would be the hardness of a mineral. So most geologists carry around a glass plate, and they can go in the field and they scratch a rock, and they see if the rock is harder than the glass, it'll scratch it, but if the glass is harder than the rock, it won't scratch it. So what I have here is gypsum again, and gypsum has a hardness of 2, so it's not very hard, and your fingernail can scratch it. It's so soft that your fingernail can scratch it. But things like feldspar will not be scratched by your nails, but they scratch glass really easily, if you want to show. So that would scratch glass easily. And the hardest mineral would be a diamond. I don't have any diamonds today, though. Alrighty. So geologists also know the Mohs hardness scale. So on a scale from 1 to 10, 1 being like talc, like a chalk, to 10 being a diamond, yeah, they can tell like what minerals are like hard, you know. So like your fingernail would be a 2.5, whereas the gypsum was a 2. So your fingernail was harder than the gypsum. And then quartz, like this one, would be a 7. I'll just put that there. Yeah, so that's hardness. Okay, so a mineral will always be able to scratch itself and any softer material, but nothing ever harder than itself. Okay. The next process would be cleavage and fracture. So cleavage and fracture is the way that a mineral breaks. So fracture would be a rock's tendency to break along uneven and angular surfaces, like broken glass. It would like shatter instead of breaking into angular, like flat pieces. And then cleavage, it breaks easily and it forms flat surfaces. So this is calcite again. It has, if you bring it up, it has 3 flat surfaces, almost at 90 degrees. And then this is muscovite. It breaks off in sheets and has one perfect cleavage plane. So that when it breaks off into the flat, kind of paper-thin pieces. If you separate those, you can see right through it if you separate them. Oh. So that's how it breaks off, the thinner one. Mm-hmm. It's super thin and flat, and that's cleavage. Cool. So our last process of identification would be our density. So galena is a really heavy mineral as compared to like hematite or muscovite. It's really, really heavy. So density is our weight or our mass of a rock. So if you would weigh it, you would get the mass of your, what is this, galena. And so this is actually, I messed it up.
Not registering.
I should wait. So your galena is about 62 grams. And if you were to put it in water, you would subtract how much water was at the level before you dropped it in and how much water was at the level after. So you would take your weight and you would take your volume and you would divide them and you would get your density. So a geologist could tell that a galena was a lot denser than a hematite or something like that. There are other really funny properties, like so that they can tell what minerals are which, and this is the more fun one. It's a rock's reaction to weak acids. So I have a really weak acid right here, and if you take this calcite,
does it matter what side?
No. It has a slight reaction to the acid. If you can see, it'll fizz and smoke a little bit. That's a chemical reaction. So most of these are physical properties of identifying rocks, but that one is actually a chemical property. So there you go. I mean, there are other ways. There's magnetism. There's taste. I wouldn't recommend tasting rocks, but some of them are distinguishable by their taste, their smell. And yeah.
That one looks tasty.
I wouldn't eat it. Alrighty, and that's it for that if we wanted to. And so those are our main properties for identifying rocks. So the experiment we have is for,
Just take this.
okay. I'll move these. Cool. So our experiment is going to be with airheads today. So a lot of rocks, geologists identify rocks, but they also need to know where a rock came from and how it formed. So some of the processes or the first, I guess, part of the cycle would be sedimentary rocks. So when sedimentary rocks are made, they start from a really big, already formed rock. And when weathering and erosion happens, and mostly by water or wind, rocks are transported. So sediments become like something is eroded, and then the sediment is transported. When it gets, so Holly right here is weathering down our rocks, our airheads, our rocks right now. She's breaking them into smaller pieces.
That one's in really tiny.
Those are really tiny. So Holly is the wind or the rain around a boulder or a big rock formation or a mountain or something. So usually sediments are transported down a river, and then they all form up and they're all mixed together. And then a process called deposition and then lithification. So deposition is when they all sit in one space, and then lithification is when they're all like cemented together. So that can be through water, like chemically active water, so that would be like hot water, or Holly pushing down on airheads. So that would make a sedimentary rock. So our airhead sedimentary rock is right there. It looks really nice. Tasty.
You said I could taste
No,
it.
you don't taste it.
Okay.
The next process would be a metamorphic rock. So metamorphic rocks are formed by heat and they're formed by pressure. So Holly is going to put our airheads in a bag and apply heat from her hands and pressure from her hands to make a metamorphic rock. So a lot of times metamorphic rocks have layers in them to where you can see the different kind of rocks that formed.
Dwayne Johnson.
So now we have a metamorphic rock. The second that a metamorphic rock melts, it becomes an igneous rock. So we have melted airheads as well to show you our igneous rocks. I think that's all I have.
We've already pre-melted these.
Pre-melted igneous rocks. Yep. And that is the rock cycle. Good. All right, thank you guys for watching. Hope to see you next time.